Hello.
Hello, yes, ma'am.
Yeah. I will start for this event. Okay.
Actually,
Okay. Yeah. Okay. Good morning, ladies and gentlemen. Welcome to the International Visiting Lecture today with Dr. Simanpreet Kaur. As for the topic today is business statistics. And for today's session is being streamed on the University STEKOM YouTube channel. And now I will lead our agenda this afternoon. First, we will start class presentation delivered by Dr. Simanpreet Kaur and continue with the Q&A session. In the next session, we have time for presentation and last time is closing. Okay, let's begin. We will start class delivered by Dr. Simanpreet. The time is yours. Thank you.
thank you, ma'am. So I will start my lecture now. It's about business statistics. Good morning, everyone. My name is Dr. Simanpreet Kaur, and I'm an associate professor at Chandigarh School of Business, Jhanjeri. So today, my lecture will be covering three major topics. First is data presentation, second is measurement scale, and third one is probability. All right. We will cover the first topic first, which is data presentation. To cover this topic, we should first understand what is the meaning of data. What is data? Data is raw, unprocessed facts, figures, or information. Collected for analysis, interpretation, and decision making. It can be qualitative or quantitative and exists in various forms such as text, number, images, audio, and video. So, what is data? Data is plenty of information, and in statistics, we require data for everything because statistics basically deals with data only, and we derive meaningful information out of this data. So, why is data important? Data is important because, first of all, it supports decision making. Organizations and individuals use this data to make informed choices. So they need data to assist their decision making process. Second one is it drives innovation. On the basis of previous data only, this data leads to newer discoveries and improvements in technology, business, and research. But third is it enhances efficiency. Businesses use data to optimize operations and reduce cost. On the basis of data only, we can gather information from the past and it can help us drive better and efficient ways uh, to optimize our operations and reduce our cost in futures. Fourth is it improves accuracy. Data helps to minimize our guesswork and subjectivity, and it helps to improve accuracy because we have background knowledge about the subject. Fifth one is it enables predictive analysis. With the help of data only, we can make forecast and future outcomes on the basis of past information. Now, the first topic is related to data presentation. So we know what data is. So why data presentation? What is data presentation and why it is important? Why are we studying data presentation? Data presentation in statistics involve organizing, summarizing, and displaying data in a way that is clear and easy to interpret. So this meaning says that data interpretation is basically presenting a lot of data in such a way that it is very easy to display and it is very easy to understand. The goal is to convey insights effectively and help readers or viewers understand patterns, trends, and relationships in the data. So it is very easy to understand if we present data in a precise form. So it refers to organization of data into tables, graphs, and charts, means something which, with the help of which we can easily uh, assist the readers or the people who are gaining information from that. They can easily understand what this data means on the basis of the tables, graphs, or charts we are making. So that logical and statistical conclusions can be derived from the collected measurements. So why is data important? First of all, why is data presentation important? Data presentation is important because, first of all, it enhances understandability. Studying such a large and vast piece of information is difficult, but if we present data in a concise form, it enhances the understandability of the reader. Well-structured data in the form of charts, graphs, tables is easier to interpret. So that is why we present data in the easier form. Second is it simplifies complex information. Visualizations, data presentation is done with basically three techniques, which we are going to study in further slides. This complex information is very easily communicated to the readers. They can easily understand uh, what the person is trying to convey with the help of uh, easy presentation and with the help of various methods of data presentation. Third is supports decision making. Data presentation helps to draw conclusions. So we can easily make decisions out of the data presented. Engages the audience. Obviously, a data which is provided in a long and lengthy way will not be very appealing to the readers. So if a data is presented in crisp form and it is presentable in appealing form, it will catch the interest of the stakeholders or the readers, and they will find it engaging. Fifth one is it ensures accuracy and transparency. Properly presented data reduces misinterpretation. We can drive meaningful conclusions out of the data presented. So what are the main forms with which the data is presented? The three major forms of presentation of data are, first one is textual, second is tabular, and third one is graphical. Out of these three forms, we use tabular and most popularly graphical method the most. Okay, we will study now one by one what is textual, tabular, and graphical form of presentation. First is textual. In the textual form of presentation, the data is gathered and it is presented in a paragraph form. Data are written and read. It is a combination of text and figure. The example of textual presentation is of the 150 samples interviewed, suppose in a college, there are 150 samples of students who were interviewed. The following complaints were noted. The students have given the following complaints: 27 for lack of books in the library, 25 for dirty playground, 20 for lack of laboratory equipments, 17 for not a well maintained university buildings. So this is textual presentation, means the data which is presented, it is in a paragraph form rather than in some table or some graphical form. So here the data is basically given in a statement form. Second, okay, now what are the uses of presenting data in textual presentation? It presents the summary, insights, and patterns in narrative form, in summary form. Advantages are it adds context to the data, especially for non-technical audience, an audience which cannot understand how to read tables and graphs. It is easier for them to gain information from textual presentation. Next is tabular presentation. So first one was textual presentation, second is tabular presentation. In tabular presentation, data is presented in table form. Like this is an example. So this is a table. So data will be provided in the table form. Method of presenting data using statistical table is a tabular presentation, a systematic organization of data into columns and rows. The information is provided under various columns and rows. So what are the various parts of a table? First one is table number. Every table has a number. Like in the top of this slide, they have given table number. If it is table number 1, 2, 3, the number of the table will be given. Second is the title. Table must bear a title. Every table depicts some information. On the basis of that information, a title is kept for the table. So second is like it is given in this table, which is given as example. Title will be mentioned over here. Third one. Third one is captions and stubs. Captions and stubs means column headings. There are different columns and rows in the table. So every column has a heading, which will be called caption. And every row has a heading, which is called stubs. All right. So here they have given in this example column heads, which will be called captions, and they have row entries. Row entries will be called stubs. Fourth point is main body of the table, which is the essential element of the table. Main body of the table will contain the information, the main information that the data that you want to present. So main body of the table is the body that contains the data or the information regarding the topic or the title. Fifth one is ruling and spacing. Ruling and spacing basically means the horizontal and the vertical lines, how much spacing or ruling you want to keep for your table. It depends upon the type of information, how much data you want to present. Sixth is the head note. In this example also, head note is mentioned. Head note, if any. Head note means sometimes the information is so vast, like if we are giving information of some currency in millions. So instead of putting so many zeros at the end of the figure or end of the digits, we write in the head note that the units of measurement are in millions. So instead of putting all this information within the column, within the main body of the table, we will give this information in the head note. Seventh one is footnote. Footnote is some explanation of the data. It sometimes there is some information which we cannot present in the table, so that information can be given in the in the footnote. If there is no information, such information that you want to give at the end of the table, then there is no need to give some explanation, or there is no need to give the footnote. Last one is source note. Source note is source of obtaining the table. Now, if you have taken the table from some secondary sources, then it is important to give the source note, the source from where you have obtained the table. In case you have made it your own table, then also there is no, you'll have to mention from what are the sources from where you have collected this data that you have presented in the table. Next is tabular presentation. Tabular presentation, okay, sorry, this is the tabular presentation only. And the uses, it is written organizing raw data into rows and columns for clarity. Like we have mentioned over here, the data is presented into rows and columns, and the advantages are easy to compare values and summarizing large data sheets. Instead of large data sheets, we are going to summarize the data and present into table in a compact form. Next is graphical presentation. Now, graphical presentation helps to present the information with the helps of graphs or lines or pie charts. So there are various types of graphs on the basis of either we are making bars or line or pie charts. So on the basis of these things, we have divided the types of graphs. First one we are going to study are the bar graphs. This is an example of bar graph. It is mentioned year 1989, 1990, 1991, 92, and 93, and the profit earned by a company. So bar graphs are basically rectangular bars which present the information. Bar graph use rectangular bars of equal width to represent data categories. The length or height of the bar corresponds to the frequency or value of the category. So this length depends upon what is the value in that year. Purpose. What is the purpose of having a bar graph? Compare categorical data, gender, age group, product sales. Like here also, they have compared the profit of the company over the period of 5 years. Then is bars can be vertical or horizontal. It depends upon what kind of bar graph you want to make. Next is example, comparing month. In this example, they have compared the profit of the company over the period of 5 years. So it is generally used to make a comparison with the help of the rectangular bars. Next one is pie chart. This is an example of pie chart. A pie chart is basically circular in shape, and this circle represents 100% of the data. And every slice of this pie chart represents how out of that 100%, how much percentage belongs to different categories. Like in this example, they have given how much water do we use. So they say that in a household, how much water is used on shower, faucet, clothes washer, leaks, toilet, and other purposes. So this whole pie represents 100% of the water used in a household, and the individual slices, individual colors of slices represent how much water in a household is used for these purposes. So pie chart is circular graph divided into slices where each slice represents a proportion or percentage of a whole. The purpose is to show relative proportions within a data set. Total percentage always equal to 100%. Example is given visualizing the market share of companies in the industries. In this pie chart, it is given in the usage of water in a household. Next, third kind of graphical presentation is line graph. So this is basically a line graph. Here, different data is gathered, and then a line is joined through that data. Line graph use points connected by line. So there are various points which are connected by line. to display data over time or continuous variable. Purpose is to show trend. Like we can use a line graph here also to represent like what is the growth of profit over the period of 5 years. So it is depends upon the researcher how he wants to present his data. So it helps to line graph shows trends, growth or decline. Applications are time series analysis means if we want to show variation over the time, such as stock prices, temperature changes or sales over months. Features are multiple lines can be plotted. In this example, only one line is plotted, but it is possible to draw multiple lines if you want to show, if you want to compare trends over a period of time. Then clear markers and legends enhances readability. Example is tracking monthly revenue of the past year. All right. Next type of graphical presentation is histogram, a type of bar graph that represents frequency distribution of continuous or grouped data. Generally, a histogram is used in continuous data. Continuous data is one data where we make groups of the data. Like I say, out of 50, some students have attained 10 marks, some have attained 20 marks, 25 marks, 35 marks. So instead of writing it in individual series, we make it how many students have gained from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50 marks. So we are making frequency distributions of continuous or grouped data. So what are the key points in histogram is bar touch each other to indicate the continuous nature of data. Continuous nature means 0 to 10, 10 to 20, like that. We make slabs of data. Example is showing the distribution exam scores among students. Like this is an example of histogram. Here they have given how many students have gained marks between 20 to 30. This is an example of age and frequency. How many are between the age of 20 to 30, 30 to 40, 40 to 50. So generally histograms are used in continuous or group nature data. Last is scatter plots. Scatter plots are basically dots which are plotted first and then a line is drawn through that plot to understand the nature of variables. Scatter plots use dots to plot values of variables on a coordinate plane where one variable is plotted on x-axis and the other one is on y-axis. Generally, scatter plots are used to understand the nature of variables. Like here, if I draw one variable, like if I want to know the impact of sales, advertisements on sales, I will draw advertisement on x-axis and sales on y-axis. Then I plot if there is any, to find out if there is any correlation between them between both of them, whether advertisement has affected the sales positively or negatively, or is there no correlation. So purpose is to visualize relationship or correlation between variables. Like we want to know the variable relationship or correlation between advertisement and sale. Types of relationships. Now basically from scatter plots we can understand what is the nature of correlation between two variables. First one is positive correlation. Both variables increase together. Like this is an example of positive and linear correlation, which point in graph number A, it says, suppose we are saying advertisement is having a positive impact on sales, then a positive positive relationship will be formed among two variables. Negative correlation. One variable increases while the other decreases. In graph B, it shows negative and linear relationship. Linear means both the variables x and y are increasing at a constant. Relationship means that if one is increasing, the other one is decreasing. Like there is a negative relationship between price and demand. If price of the product is increasing, the demand decreases. So there is an opposite relationship. So in that case, we will get graph B after plotting the dots, after plotting the scatter diagram. Third one is no correlation. In sometimes we can say that after drawing the graph, we do not get any proper shape of our line. So this is an example of no relationship x and y. Like if we say if we say that if we compare some factors which have no relationship with each other, then we will get a graph like this. Example is comparing advertisement expenses and sales revenue. This we have already discussed. So conclusion, why have we studied this data presentation? Why have we studied these methods? Because it is very crucial as it transforms raw data into meaningful insights. And these meaningful insights will help to make it easier to understand, interpret, and communicate the data. Effective data presentation simplifies complex information, enhancing decision making, and allows for better comparison and trend analysis. It ensures clarity, accuracy, transparency, reducing the chances of misinterpretation. Visual presentations, visual with the help of graphs, charts, or tables, it helps to engage audience, highlight key patterns, and supports data-driven strategies in various fields, including business, research, and education. Ultimately, well-structured data presentation helps convey essential information efficiently, leading to informed and effective decision making. So this is all about data presentation, which was the first part of this presentation of business statistics. Now we will begin with the second part, which is measurement scales. So before studying the measurement scales, we should know what measurement scales mean. Measurement scales are a system used in research and statistics to classify, order, and quantify data. Earlier we have studied what is data. So we know what is data now. Data is vast piece of information. It is basically a lot of information, and we drive meaningful conclusions out of that. To drive these meaningful conclusions, we need to know what kind of data we are dealing with. So measurement scales are a system which is used in statistics and research to classify, order, and quantify data. We should know what kind of data we are dealing with so that it can help us to derive meaningful conclusions out of that. They define how variables are measured and what type of mathematical operations can be performed on them. Once we know what kind of data we deal with, then only we can apply some mathematical operation on that. Proper understanding of measurement scales is essential for choosing the right statistical technique and ensuring accurate data analysis. So now we will discuss the types of measure.
Sisi Sari rangkaian dan ini dengan cara diatur dengan cara
So now we will discuss what are the various kinds of measurement scales there are. There are 4 kinds of measurement scales. First one is nominal, second one is ordinal, third one is interval, and fourth one is ratio scale. Firstly, we will discuss nominal scale. Now, there are 4 types of scales: nominal, ordinal, interval, and ratio. Now, we'll focus one by one. What is the meaning of these 4 types of scales? First one is a nominal scale. A nominal scale classifies data into distinct groups or categories without any inherent ranking or order. In a nominal scale, we just name the various elements. We just divide them into distinct groups or categories, but we do not provide ranking or order to them. Means, like if I say, in this example 4 is given, eye color. If I divide the students on the basis of eye color into blue, brown, and green, I'm just naming them that these are the students with blue eyes, brown eyes, or green eyes. I'm not giving any rank or order, which is better, which is behind, or which is above. So there is no rank or order given. It is just providing a category or a group to the data. It is the most basic level of measurement and is primarily used for labeling or identifying variable. Now, like they have given the examples, if I divide the data on the basis of gender, nationality, types of businesses, or the eye color, it is a example of nominal scale. Next is ordinal scale. In nominal, I'm just giving the name, but in ordinal, I will also give the order. An ordinary scale categorizes data while also providing a meaningful sequence or ranking. Like if I, in a race, I'm saying the student has come, this student has come first, second, third, fourth, fifth, sixth, like that, I am providing orders to the student. So this is an ordinal scale. However, the difference between the ranks is not precisely defined or consistent. I know which student has come first, I know which student has come second, third, or fourth, or so on, but I do not know by how much seconds first student has beaten the second student in the race, or the second has beaten third student in the race, or so much. So the difference between rank is not known, but the order or the sequence is known. Examples are given: customer satisfaction. Like I'm asking the customer, is he satisfied with the product? Very satisfied, very dissatisfied, dissatisfied, neutral, satisfied, or very satisfied. But I do not know what is the difference between very dissatisfied or dissatisfied. What is the exact figures or digits by which he is dissatisfied or very dissatisfied? So the rank is known, uh, but not the precise or consistent figure by which one rank is beating the other rank. Education level: high school, bachelor's, master's, or PhD. Economic class: low income group, class, middle class, high income group. Pain level in medical assessments: mild, moderate, severe. So these are the examples of ordinal scale. So a nominal scale is one where we are giving different categories, and order scales are one where we are given different ranks. Third one is interval scale. Now in an interval scale, unlike ordered ranking, we have a figure also. An interval scale provides not only an ordered ranking but also equal interval between values. Like they are saying that temperature is 20 degree or 30 degree or 40 degrees. So I have values as well. However, it lacks a true 0 point, meaning 0 does not indicate a complete absence of attribute being measured. This line means that if I am studying temperature, I know what 10-degree temperature means, 20-degree temperature means, 30-degree temperature means, but it lacks a true 0 point. Means 0 means, meaning 0 does not indicate a complete absence of attribute. Means if there is 0 temperature, it doesn't mean that there is no temperature. There is still some temperature. 0 temperature has a meaning. So it lacks a true 0 point, meaning 0 does not indicate a complete absence of attribute being measured. Because 0, it does not mean that there is no presence of temperature. 0 still means that there is some temperature, it is cold or like that. So this 0 does not indicate a complete absence of the attribute being measured. Ratio scale. Ratio scale is the most advanced measurement of scale. It has the properties of interval scale, but with a true 0. Here, 0 means something like if I'm saying a height of 180 centimeter is, if I'm saying a person weighing 80 kgs is twice as heavy as 40 kgs. Here, 0 means something, but allowing for meaningful ratio comparison. 0 means absence of something. In case of interval scale, we didn't consider 0. In case of ratio scales, 0 has a value. If I'm saying a height of a person is 0, is this possible? No. So here, 0 has a value, but with a true 0 allowing for meaningful comparisons, one value being twice the other. If a person is of 20 centimeter, then 40 centimeter, 50 centimeter, 60 centimeter, it means something. 160 centimeter, 180 centimeter, so it means something. This is the comparison table of all the 4 measurement scales. First one is nominal, second is ordinal, then is interval, then is ratio. First particular is sequence of variables. In the nominal scale, we are not establishing any sequence of variables, which means that if I'm categorizing the students on the basis of eye color, I'm just categorizing, but I'm not making a sequence. In case of ordinal scale, there is a sequence established, like we have talked about the race: first, second, third, fourth, fifth. In interval scale also, there is a sequence established, like temperature 20 degree, 30 degree. In ratio scale, obviously, there is a sequence established because we know the exact values: 160 centimeter, 180 centimeter, and so on. A second particular is mode can be calculated. In nominal scale, yes, mode can be calculated. Mode is the figure or is the value that has mostly occurred in the table. So if I'm saying I'm dividing the students male and female, 3 students are male, 2 are female, so the mode will be male. So in the nominal data also I can calculate mode, and all other forms also: ordinal, interval, ratio. This is also possible in this. Median. In case of nominal scale, median is not possible, but in case of ordinal, interval, and ratio scale, median can be calculated. Like I say, there are 11 students in the race. So the 6th student is the median because 5 students are below him and 5 students are ahead of him. So in the case from ordinal scale onwards, we can calculate median as well. Mean. Mean can be calculated in interval and ratio scale only, because here we have values or figures provided. In case of ordinal and nominal scale, we cannot provide because it is just an order, and in case of nominal, it is the name of the element. So we cannot calculate mean. Fifth one is difference between variables can be calculated. Now difference can be only calculated in case of interval and ratio scale, because here only we have values given. Like we took example of temperature 20 degree, 40 degree, we can find out the difference. In case of ratio also, height is 180 centimeter, 160 centimeter. There is a difference of 20 centimeters. So we can find differences in case of interval and ratio scale only. Next is addition and subtraction of variables is possible. It is again possible in case of interval and ratio scale only. Multiplication and division of variables is possible. This is possible in case of ratio scale only, because here we can say that the height of the person is 160 point something. Or we can say, if we calculate in feet and inches, the height of a person is 5 feet and 8 inches. So multiplication and division of variables is only possible in case of ratio scales. Absolute zero does not exist in nominal, ordinal, and interval scale. It only exists in ratio scale. That is why it is saying that in case of ratio scale, we have a true zero value. So this is all about the measurement scales. But whenever we are using these measurement scales, there are some common misuses or errors that a person makes while using these measurement scales. These measurement scales are very important to understand, as whenever we apply some tests or techniques, we need to focus on what kind of data we are dealing with. If we are not clear about whether we are dealing with nominal scale, ordinal scale, interval scale, or ratio scale, we will not be able to provide proper tests and techniques on the data, and we will not be able to get meaningful conclusions out of that. We may bring out wrong information if we are not clear about the type of data we are dealing with. So the common misuses or errors in the measurement scales are, first one is misclassifying data into the wrong scale. This is the most common mistake, one of the frequent errors in assigning data to incorrect measurement scale. Like if I'm saying I am treating, my data is nominal, but I'm treating it as ordinal. Like we took an example of the students with 3 eye colors, brown, green, and blue. If I'm saying brown, giving brown as 1, green eye color 2, blue eye color 3, I'm just giving them names only, 1, 2, 3. This doesn't mean that I have given them order. I have given them order that which is better than the other one, or which is behind the other one. So if I'm making some mistake, if I'm treating my nominal data and ordinal data, nominal data as ordinal data, it will obviously bring wrong results in my research or statistics. Second one is using inappropriate statistical methods. So we have done in this example, like mode can be calculated on all types of data. Median can be calculated on 3 types of data. Mean can be calculated on only 2 types of data. Now, if my data is nominal and I'm calculating mean, this means I am bringing out wrong information and I'm using inappropriate statistical data. Again, if I'm calculating median of nominal data, it means I'm using wrong or inappropriate statistical technique on a different kind of data. So applying the wrong statistical technique to a given measurement scale can result into incorrect interpretation. Examples are calculating the mean of nominal data, finding the average of eye colors of nationality is meaningless. It will not derive any meaningful conclusion. Overinterpreting differences in ordinal data. Now we are talking that there are example is given over here, employee performance ranking. If employees are ranked from 1st place to 10th place, this does not mean that the difference in performance between 1st and 2nd place is same as 9th and 10th place. There can be a difference also. So ordinal data is just giving us the order, but it does not give us the points of differences between the 2 orders, 1st and 2nd, 2nd and 3rd, and so on. So ordinal data ranks items but does not define the exact difference between them. Misinterpreting these rankings can lead to misleading conclusions. Fourth one is treating interval data as ratio data. Interval data does not have true zero, but ratio data has. So ratio-based comparison should not be made on data which is of interval scale. Now, this is an example given, temperature in Celsius. 40 degree is not as twice as hot as 20 degree because 0 degree is absolute absence of heat. So if we are treating one kind of data to another kind of data, it will obviously bring wrong results. Conclusion of measurement scales. Measurement scales play a crucial role in research and data analysis by defining how variables are categorized, ordered, and quantified. Understanding the four types of data. The four types which we have done is nominal, ordinal, interval, and ratio. So they ensure accurate data classification and help in selecting appropriate statistical methods. Proper application of these scales allow for meaningful data interpretation, effective decision making, and reliable results across various fields including business, healthcare, and social sciences. Misusing measurement scales can lead to incorrect conclusions. So it is essential to apply them correctly based on the nature of the data. By recognizing their differences and limitations, research and analysts can ensure precise and effective data analysis. So this is all about measurement scales. In measurement scales, we basically need to focus on the four types of scales that there are, and we need to know how to categorize our data under these different scales. We need to know what data is of what kind of scale so that we can choose appropriate statistical techniques to apply on this data. The last topic for the day is probability. So we need to understand what probability is. The term probability refers to an event, the happening or non-happening of which is uncertain or contingent. It means a chance, a possibility, a likelihood, or an odd. Example, if I'm studying theory of probability and I want to know possibility of rain today. So probability, like suppose people make a guess, it is 80% chances of having rain today, 60% of chances of having a rain today. So they are making use of probability to identify the chances of happening or non-happening of an event, of an uncertain or contingent event. There is a chance probability of getting a first class. Like if we say a student is he is very much involved in his studies, so we can say that the probability of him getting in a first class are more than the student who does not focus on his studies. So theory of probability generally deals with this chance events where we make a where we make a prediction about what are the chances of an event happening or non-happening. Value of probability generally lies from 0 to 1. The value of probability, the lowest value of probability is 0 and the highest probability value is 1. What does 0 means? 0 means that there are no chances of an event happening. Like if I say that there are no chances of of raining today, that means the probability is 0. 0 means the happening of an event is impossible. And 1, if I say that it will definitely rain today, I know that it will definitely rain today, that means I am assigning it a probability of 1. 1 means happening of an event is very certain. And all the values of probability will lie from 0 to 1. The values which will be closer to 1 will have a high probability of happening, and the values which will be closer to 0 will have a lower value of lower chances of happening. Definition of probability. The term probability may be defined as a quantitative value of chance because we are providing a value between 0 to 1. So it is a quantitative value of chance that an event will take place in face of favorable and unfavorable ways, both of which are equally likely. So we are giving a quantitative value to an event if the chances of it are equally likely. So here they have given the formulation of probability of happening of an event is equal to m plus n. M means number of favorable ways and n means number of unfavorable ways. Like they are giving, suppose we take an example of if I toss a coin, either head can come or tail can come. If I want a head, chances for me of happening is 1/2 because either head can come or tail can come. So 1 by 2 is the possibility of getting a head, and 1 by 2 is the possibility of getting a tail. Now P plus Q here means, P here means chances of having a favorable outcome. If I want a head, that means my favorable outcome, my value of P is 1 by 2. Plus Q, Q means the chances of having an unfavorable outcome. Unfavorable for me is tail. It is again 1 by 2. It is always equal to 1. So the probability of happening of an event or not happening of an event is always equal to 1. Now there are various concepts which are related to the probability. First one is experiment. What does the experiment means in the theory of probability? Experiment is an operation which produces some result or outcome. Example, tossing a coin. So experiment is the operation which has the capability of bringing out some result. They have given the example of tossing a coin, where you can either get a head or a tail. Or another example we can take is rolling a dice, where we can get a value of 1, 2, 3, 4, 5, 6. Space. What is a space? It is set of all possible results or outcomes of an experiment. Like if I toss a coin, my space will be head, comma, tail, because I can either get a head or a tail. The example given here includes space is equal to HH, HT, TH and TT. It means they have given an example by taking, if I toss two coins, what are the possibility that I get head on both the coins? What is the possibility that on first I'll get a head and second one I'll get a tail? What is the possibility on the first coin I get a tail, and on the second one I get a head, and last one is on both the coins I get a tail. So they have given the space of of tossing two coins simultaneously. So what is space? It is a set of all possible results or outcomes of an experiment. Third one is sample point. Each one of the possible results of the experiment represents an element of the sample space. Like in the second point, we have done the meaning of space. It is given HH, HT, TH and TT. All these individual points are sample points. HH is a separate sample point, HT is a separate sample point, TH and TT. Fourth point is, what is an event? An event is a case of interest which has the capability of happening or taking place to a marked extent. Like if I want, which is the event is the case of interest. Like if I say, what is the possibility that the both coins, if I toss two coins, both fall alike, means I either get HH or TT. So event is that case of interest which has the capability of happening. Now we will study what are the types of events. There are various types of events. First one is sure event. Sure event is an event which has the certainty of happening. Sure event is the one which has the probability equal to 1. Means this event is going to happen certainly. It is going to happen for sure. That is a sure event. Second one is impossible event. An impossible event is one which can never take place, which means that the possibility or the probability associated with an impossible event is 0. Impossible event is the one which can never take place. Third one is random event. A random event is one which the occurrence of which is uncertain or contingent. Like if I say I toss two coins, what is the probability of getting a head on the first and a tail on the second coin? So random event is the one whose occurrence is uncertain or contingent, or you're uncertain about what will happen in future. Elementary event, an element of sample space which represents all possible outcomes of a random experiment. Thus every sample point is an elementary event. Like in this example we have taken, if I toss two coins, either we can get heads on both coin, head on first, head on second, or tails on both. So all these separate sample points are elementary events. Next one is simple event. What is the meaning of a simple event? A simple event is one or single event, the probability of which is under consideration. Probability of such an event is considered by PA, where A is an event. Simple event is one. Suppose I'm taking an example that in a bag there are 10 black balls and 10 red balls. What is the probability that I draw one ball and it is red ball? So what is the probability? The bag has 10 red balls and total balls 10 black plus 10 red are 20. What is the chances of getting a red ball is 10 out of 20. So this is a simple event. A single event. A single event, the probability of which is under consideration. So I'm just defining the probability of getting a red ball. Compound event is one when two or more events are joined together and two or more events occur jointly and the probability of joint occurrence is in consideration. Like I want that out of a bag, we have two color balls, 10 are black balls and 10 are red balls. And I draw two balls out of that bag without replacement. So what is the probability? Now, the probability of getting first ball, suppose I want first ball as red ball and second one as black ball. So the probability of getting first ball as red is 10 by 20 because there are 10 balls in the bag and 20 total balls. But now I'm not replacing the ball again in the bag. Now the balls left in the bag are 19 only. So when I make a second draw, I want a black ball. So the probability will be 10 black balls are there in the bag, 10 black balls divided by 19. So 10 by 20 and the second is 10 by 19 means it is a compound event. Now two or more events are occurring jointly and I want to know the probability of the joint occurrence of both the events. This will be compound event. In case of single event or simple event, I just drew one ball and I want to know what was the probability of getting that particular color of ball. So this is the difference between simple event and compound event. Next one is independent event. An event, the occurrence of when is not dependent upon the occurrence of any other event. Like we took an example in case of single event that there is a bag containing 10 red and 10 black balls. What is the probability of getting a red ball? The probability of getting a red ball is 10 by 20 because this is an independent event. It is not dependent on anything. Whereas the second type, which is dependent event, here I'm here it means that occurrence of which is affected by probability of preceding event. Like we took the example of 10 red and 10 black balls. Firstly, I want a red ball, the probability of which is 10 by 20. Second, I want a black ball, the probability of which is 10 by 19. Now, the probability of my second event is dependent upon the first one. That is why my denominator has reduced. Now, if I say I also want a third draw. In the third draw, I again want a red ball. The probability will be 9 by 18. Now again, my probability is dependent on my preceding events. So if your event is depending upon your preceding events, it's a depending event. If it is independent of the previous events, it is an independent event. Then are mutually exclusive events. What are mutually exclusive events? Two or more events that are taken as mutually exclusive if the happening of one excludes or prevents the happening of another at the same time. Like I said, I toss a coin. I can either get a head or a tail. So they are mutually exclusive events. In no case, both the things, head and tail, can come together. There are no chances of this thing happening. So mutually exclusive events are those events in which if one thing has happened, if head has come, there is no chance that now tail can come. Only there is possibility of happening only one event. So if the happening of one excludes or prevents the happening of another event at the same time, it is a mutually exclusive event. Like in case I have rolled a dice and 3 has come on my dice, that means 1, 2, 4, 5 and 6 are, there are no chances that those values can come. So these are mutually exclusive events. Then are overlapping events. Two or more events that can take place together are called overlapping events. If in any chance there are some events that can overlap or they can happen together, then there are overlapping events. Equally likely events. Equally likely events means if I'm talking about two or more events together, there are equal chances of happening of all these events. So each of them has the equal chance of happening and none of them is expected to occur more often than the other. Like I'm taking that I roll a dice, there is an equal chance of coming 1 also on the dice, 2 also, 3 also, 4, 5 and 6. In no way it is possible that the value 6 has more chances of coming than all the other 5, 1, 2, 3, 4, 5. There is no chance that 4 can come more times than 1, 2, 3, 5 and 6. So equally likely events are that the chances of happening of event has the equal chance of happening. Complementary events. Complementary events are two events are said to be complementary to each other if they are mutually exclusive and exhaustive as well. Thus, when when a dice is rolled, the outcome of an even number will be complementary to the outcome of odd number. Which means, like, if I want an even number on my dice, 2, 4, 6, the complementary, the opposite of it will be 1, 3, and 5. If on a coin I want a head, the complementary event will be tail. Okay, I will take the queries at the end. Now, there are two rules of probability, rules or theorems of probability. Two theorems of probability. First one is addition theorem and second one is multiplication theorem. While calculating probability, we take care of both these theorems together. First, we take care of these both theorems to calculate the probability. So first one is addition theorem, second one is multiplication theorem. Now we will study both these theorems one by one. First one is addition theorem. According to this rule, the probability of two or more related events will be summed up to find out the probability of joint occurrence. This is the formula of addition theorem. Like if I say, what is the probability of an event A and B happening? The probability is P, probability of getting an A event plus probability of having a B event. Like if I take an example that I have a pack of cards or I have a pack of playing cards. What is the probability? I have drawn one card at random. What is the probability that that card is either a spade or a club? Now, how many spade cards are there in a pack of 52 cards? There are 13 cards which are of spade, and there are 13 cards which are of club. So what is the probability that the card I have drawn is either spade or club? Having a spade is, the probability of getting a spade is 13 by 52 because there are 13 cards in a pack of playing cards and 52 are the total number of cards. So 13 by 52 is the probability PA, probability of getting a spade. PB, which is the probability of getting a club, is again 13 by 52 because there are 13 club cards in the playing cards and 52 are the total cards. So what is the probability? What, according to addition theorem, probability of A and B, probability of getting a card which is either club or a spade is 13 by 52 plus 13 by 52, which is 26 by 52. That means 1 by 2. So this is the rule of pure addition. Means we use the P, probability of one event plus probability of second event, to calculate the final probability. All related events are added together to compute the probability of their joint occurrence. This rule is applied where all related events are mutually exclusive of each other. Mutually exclusive, we have already studied. The occurrence of one, only occurrence of one thing can happen and it eliminates the occurrence of the other thing. Now, in this addition theorem, sometimes we also use subtraction. The probabilities of related events of exclusive nature are added and that of inclusive natures are deducted. In that case, our formula becomes probability of AB is equal to probability of A plus probability of B minus probability of AB. What does this minus means here? Why are we subtracting here? Like suppose we take an example. I have cards. Suppose I have a piece of papers on which I have written 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20. Suppose I am drawing one piece of paper out of those numbered papers, out of those 20 numbered papers, and I am drawing one paper on which it is written and I have drawn one paper. And what is the probability? I want to calculate what is the probability that the number I am drawing is a multiple of 3 or 4. Now, if I want to know, I want to understand what is the probability of getting a multiple of either 3 or 4 out of those numbered 1 to 20 numbered papers. Now I have to find out probability AB. Here, probability of A means probability of getting a number which is multiple of 3 is either I can get 3, 6, 9, 12, 15, 18 because the numbers are maximum up to 20. Now probability of B means probability of getting a 4, multiple of 4 is 4, 8, 12, 16, 20. Now, I have studied that if getting a probability of multiple of 3 is 6 by 20. There are 6 papers out of those 20 papers which are a multiple of 3. That means the probability of getting a multiple of 3 is 6 by 20. And the probability of getting a multiple of 4 is 5 by 20 because it is 4, 8, 12, 16 and 20. So probability of getting a multiple of 3 is 6 by 20 and probability of getting a multiple of 4 is 5 by 20. But there is one number which is 12, which also comes in which is also a multiple of 3 and also a multiple of 4. So out of those 1 to 20 numbers, we have a number 12 which comes in the table of 3 also, which is a multiple of 3 and which is also multiple of 4. So it is an element which is included or which is a point of intersection between both the multiples. So such elements will be reduced. So what will be my final probability? Final probability will be PAB means probability of getting a multiple of 3 or 4 is equal to probability of multiple of 3 6 by 20 plus probability of multiple of 4 5 by 20 minus probability of a number which has come in both which is 12. So minus 1 by 20. So this is how I will get a final probability. So any figure which is inclusive in nature will be deducted in case of addition theorem. Next is multiplication theorem. The probability multiplication theorem says the probability of simultaneous occurrence of two events A and B is equal to the product of probability of each other, given the first one has occurred. This is called multiplication theorem. This also we will study with the help of an example. Example says there is a known that contains 20 red and 10 blue balls. Two balls are drawn from the back, one after the another. Now I have drawn two balls. First one I have drawn. After that, I drew one more ball without replacement. Now the first ball I have drawn from that urn, I haven't kept it again in that. And I have drawn a second ball. What is the probability that both the balls drawn are red? What is the probability of getting both balls as red? Let A and B denote the events. I'm again using PA and PB. PA suppose red balls hai, and PB is suppose it is blue balls. So let A and B denote the events that first and second drawns are red balls. We have A intersection B. So what is the probability of getting a first red ball is 20 by 30 because there are total 30 balls in that bag. So what is the probability of getting a first ball as red is 20 by 30. Now, on the basis of conditional probability, or we have studied dependent events. Now, second ball also I want a red ball. But now, what will be the probability of getting a second red ball will be 19 by 29. Because in the numerator also one ball has deducted and in the denominator also one ball has deducted. So, the final probability according to multiplication theory is 20 by 30 into 19 by 29, which is 38 by 87. So these are the two theorems of probability, addition theorem and multiplication theorem. Now further type which we want to discuss is the observed and expected frequencies. When we are studying probability, we have two kinds of frequencies. First one is observed frequency and expected frequency. Probability is used to study expected frequency because observed frequencies are something which has happened or which has actually taken place. So observed frequencies are counts made for experimental from the experimental data. In other words, you actually observe the data happening and take measurements. For example, you roll a dice 10 times and then count how many times each number is rolled. The count is made after the experiment. Expected frequencies are count calculated using probability theory. For example, before rolling a dice, you calculate what is the probability of any number you rolled. So for the purpose of probability, we need expected frequencies. Observed are the ones which has actually happened. So when we use probability theory, we make a list of what can be the expectation. Like they have taken an example of rolling a dice. What is the uh, probability of getting a 1 on a dice, 2 on a dice, 3, 4, 5, 6, 7. So I'm sorry, 3, 4, 5, 6. So I am writing the expected frequency that can happen, or which I am expecting to happen on used calculated on the basis of probability theory. Types of theoretical distributions. Now, probability basically deals with three kinds of theoretical distributions. First one is binomial distribution, second one is Poisson distribution, and third one is normal distribution. The first two are discrete in nature and the last one is continuous in nature. Now, what are discrete and continuous? There are three kind of series. First one is individual series, discrete series, second one is, and third one is continuous series. Like if I say the number of marks earned, how much marks are earned by 5 students in the class. First one has earned got 10 marks, second one has got 20, third one has got 30, fourth one has again got 20, and last one has got 10. This is an example of individual series. Now, if I say discrete series means if I say how many of the students in the class, there are 5 students in the class, how many have got 10 marks. So I'll say 10 marks are 10 marks are gained by 2 students, 20 marks is gained by only 1 student. So this is discrete data. Continuous data says, like if I say how many students have got marks between 0 to 10, 10 to 20, 20 to 30, and so on. So binomial and Poisson distribution basically deals with data which is discrete in nature, but normal distribution deals with data which is continuous in nature. Now we will study all these distributions one by one. First one is binomial distribution. Binomial distribution was given by Jacob Bernoulli, a Swiss mathematician in 1700. So binomial distribution, as we have studied in an earlier slide also, it is a discrete probability distribution that gives only 2 possible results in an experiment, either success or failure. Like if I say I toss a coin and there could be only 2 possible outcomes, head or tail. And if any test is taken, then there could be 2 results, pass or fail. So this distribution is called binomial probability distribution. What are the assumptions of binomial distribution? First of one is n is finite. N means like if I say I have tossed 2 coins, so my n value will be 2. If I say I have tossed 10 coins, so it will be n will be 10. So n is finite number. If I say I have 2 coins which I have rolled 10 times, that means I have rolled it 2 coins 20 times. 10 in 2 into 10, 10, 20. So n is always finite. N is a number. It is not infinite number. It is a finite number. Second assumption is saying only 2 possible outcomes are possible, which are mutually exclusive. Like I say, mutually exclusive, only 2 possible outcomes. In case of if I toss a coin, either head is possible or tail. So there are only 2 possible outcomes and they are mutually exclusive. One is happening, the other is not happening. Third one is the probability of happening of an event P remains constant in all the trials. The probability of an event P means chances of getting a success. Like if I toss a coin and I want a head, that means for me chances of success are getting a head. So getting ahead means the probability is 1 by 2. So the probability of happening of an event is 1 by 2 and it will remain constant in all the trials. It will not change how many coins I use. If I toss 10 coins or 20 coins, my probability associated with my chances of success P will remain 1 by 2 only. The probability of not happening of an event Q is also going to remain the same. It will also remain constant. Like if I say I want a head, but my chances of non-happening of an event means I do not want a tail. So the probability of getting a tail is also 1 by 2. So the probability of not happening of an event will also remain constant in all the trials. All trials are independent. They are not dependent. One trial is not dependent on the preceding event. All trials are independent of each other. This is the model which is for binomial distribution. It says NCR P raised to power R, Q raised to power N minus R. Here N means number of experiments. Like if I say I have 4 coins, so my N value of N will be 4. C is the combination. We know permutations and combinations, so C is used for the combination. R is events in the trial. Like if I have 4 coins and I want a head. What is the probability? R here is given 0, 1, 2, 3, 4. Means what is the probability that I will get no head on any of the 4 coins? Means 0. What is the probability that I only get a head on 1 coin? That means 1. R is equal to 1. What is the probability that out of those 4 coins I get head on 2 coins? That means R is equal to 2. What is the probability that I get head on 3 coins out of 4? That means R is equal to 3. And what is the probability that I'll get head on all the 4 coins? That means R is equal to 4. So the value of R will change accordingly. P is the probability of success in a single experiment, like we took chances of getting a head 1 by 2. Q is the probability of a failure in a single experiment, which is 1 minus P, or like we have assumed in our chances of getting a tail, which is 1 by 2. So this is the model for binomial distribution. Second one is Poisson distribution. A Poisson distribution is a tool that helps to predict the probability of certain event happening when you know how often the event has occurred. It gives us the probability of a given number of events happening in a certain interval of time. A Poisson distribution, first of all, Poisson distribution was given by Simon Denis Poisson. He was a French mathematician. And in case of Poisson distribution is used to help to find out frequencies of rare events where P is very small. So Poisson distribution is generally used in the events which are very rare to happen. Like if I take an example, there is a unit, we say, what are the number of bacteria in a unit? F1 need to find. So the chances of happening or the chances of success of an event are very small in case of Poisson distribution. Like if I say there is a very high quality machine. So what are the chances of having defective pieces in a high quality machine? So here chances of getting defective products in a high quality machine, it will be rare. So Poisson distribution is generally considered to find out the theoretical frequencies of rare events where the value of P or where the chances of happening of an event are very small. The assumptions are the happening or non-happening of any event does not affect the happening or non-happening of another event. Second is the probability of an event happening of more than one event is very small. Interval is negligible. The probability of success for a short interval or a short space is proportional to the length of the time interval or space interval, as the case may be. The formula or the model for Poisson distribution is P, in bracket we have R. P means probability. R is again the chances of an event is equal to E is the Euler's constant, and the value of E raised to power minus M. Here M means the mean or the expected value of the variable. Now mean will be find out with the formula of mean, and E raised to power minus M, and the value of this value can be we can extract from the table value of this Euler's constant. And into multiply by M raised to power R. M is again here means the mean or expected value of the variable raised to power R. R is again the number of success of the event. 0, chances of having a defective product. 0, 1, 2, 3, 4, 5, and so on. And divided by R factorial. R again here means number of success for an event, and factorial means the formula we have to provide. Like if it is 4 factorial, the answer will be 4 into 3 into 2 into 1, and so on. So with the help of this formula, we can find out the value of the probability associated with the help of Poisson distribution. Last one is the normal distribution. Normal distribution, which is also called Gaussian distribution, is the probability distribution that is symmetrical about the mean, showing that the data near the mean are more frequent in occurrence than the data far from the mean. Distribution curve can be divided in the middle to produce two halves. The symmetric shape occurs when one half of the observations fall on each side of the curve. Now I will show you what a graph of a normal distribution looks like. So this is the graph. A normal distribution is generally, it appears to be a bell curve. So this is the graph which shows how a normal distribution looks like. Now all the data we have studied, or we have, suppose as a researcher I have gathered my data, and my data will fall under this. If my data is normal, it will fall under this bell curve only. Now this bell curve, we have shown it in other form also. This bell curve, I have shaded the area in this graph is shaded green, yellow and red. What does these shaded areas show? The green area shows 68.2% of the total data that is collected by the researcher falls under this green area. That means majority of the data which is collected by the researcher falls under the green area. Then the yellow area includes the 95.4% of the information collected by the researcher will fall under this area, and 99.7% of the information collected by the researcher will be covered under red, green and yellow combined area. So this is a normal curve. What are the properties of this normal curve? Normal curve is symmetrical. Symmetrical means this normal curve is bell in shaped. It is not inclined either to the right or the left. So this is what symmetrical means. This normal curve is always bell shaped. It is always symmetrical. Second one is the normal curve is unimodal. Unimodal means it has one mode. Like we are saying that there is a point 34.1%, on the other side also 34.1%. There is a line drawn which divides the normal curve into two equal parts, and this line, the common line, is the line where mean, median and mode lies, and on this line only mean is equal to mode is equal to median. So this normal curve is unimodal, means it has single mode. Mean, median and mode coincide, like we have studied on this central line. This line which divides the bell into two shapes is the line on which the mean, median and mode are coinciding, means they are one, their value is equal. Fourth one is the maximum ordinate occurs at the center. The maximum ordinate occurs at the center means it is the point where the bell is the highest. This is the point which is the highest. Normal curve is asymptotic to the x-axis. Okay, this means that the normal curve, like here also it is shown, the normal curve will make a bell, and when it falls below, it will not touch the x-axis. It will remain, we can see this thing, it looks closer to the x-axis, but it will never touch the x-axis. So normal curve is asymptotic to the x-axis. Next point is the point of influx occurs at point +1 -1 standard deviation. This means that the point of influx, this bell, the bell from where the shape of the bell changes, happens at -1 +1 standard deviation, then -2 +2 standard deviation, -3 +3 standard deviation. So the point of influx of the curve will change at these plus minus standard deviations only. Next is total percentage of the area of the normal curve within 2 points of inflection is fixed. The total area, percentage area, like it is covered, 34.1 is on this side, 34.1 is on that side, 13.6 is on this side, 13.6 is on the other side. Then again, 2.1, 2.1. So this area is defined. The total percentage of area of normal curve within 2 points of inflection is fixed. Next point is normal curve is a smooth curve. It is not a histogram. Like we have earlier done in data presentation, what is an histogram? So normal curve is a smooth curve. It is not a histogram. It is not of different bars, rectangular bars. It is a smooth curve. Next is greater percentage of cases at the middle of distribution. The greater percentage of cases lies in the middle. Like it is given in green area. Like the majority of your data will be covered under this portion, this green portion. The scale of x-axis is normal curve is generalized by z deviates. we can find the value of z also. There is a formula for this, x minus x bar. But it will include in numericals only. For theoretical portion, scale of x-axis is generalized by z deviates. So that's all for my presentation. Thank you so much.
Thank you so much for your presentation, Miss. We have one question already read in the Zoom chat.
Okay, the question is, how can we ensure that statistical data used in business decision making is not manipulated or misinterpretation to support a specific agenda? Okay, whenever we study business statistics, the first and actually the most infamous limitation of business statistics is that data can be misinterpreted and manipulated in statistical in statistics. So it depends upon the integrity of the researcher to choose that data which is trustworthy. Never take a data from untrusted websites. And whenever you take data, like if I take an example of secondary data, never follow those websites which are not trustworthy. Always take the data from trustworthy websites, and whenever you drive conclusions or whenever you write a research paper, always mention the source from where you have mentioned the data. So if your source is reliable, for the reader also, or for the other person who is reading your paper, or who is trying to understand what you have written, he will also rely on the data that you have presented, because now he know that you have got the data, your source of data is reliable. So the major limitation of statistics is that data can be manipulated or misinterpreted, and it depends upon the integrity of the person, that he uses trustworthy data and he draws conclusions which are trustworthy, and he does not manipulate the data. So it is entirely upon the person how he handles the data. He should not manipulate or misinterpret the data. What are the limitations of statistical models in predicting business trends? There are various business statistic techniques like regression, which are used to predict business trends. And regression is actually the one which is used to forecast past data, use past data to make forecast about the future. Like I say, suppose we need to know what are the forecast of ice cream sales on the basis of temperature in summers. Now, obviously, on the basis of past data, we can infer this thing, that the sale of ice creams have generally increases in summers. So these statistical models, these regression models, these helps to make the future predictions on the basis of past data. And how can businesses mitigate risk associated with inaccurate forecast? Business mitigate risk. This is one thing. Statistics actually helps to draw conclusions from past data. Now, it may happen that the future, because future is uncertain, it is vulnerable, it is uncertain, it is contingent, so anything can happen in future. But we have statistics just helps us to make forecast and to associate probability of happening of that event. In real world business scenarios, how do companies balance between statistical and practical? In real business scenarios, companies, what they do is they are using statistics, they are using regression models, or you can say they are using the various techniques. There are so many tests which are in business statistics which are used to make make predictions about the future. So what these companies do, they make use of these statistical techniques, and then they use them to make sound decisions about future of their companies. Big data and AI are revolutionizing business analytics. How do traditional statistical methods stay relevant in this rapidly evolving landscape? There are so many softwares from SPSS, eViews to there are like R and all these softwares. They are helping the businesses to evolve with the help of AI. There are mainly there are some so beneficial softwares that you do not have to bother so much about putting the data and all these things. You just have to enter the data and it will give you the answers also, and it will give you the summary also. It will give you the interpretation also, that what the software has drawn from your data, and you can easily infer from that. So AI is basically helping the people to the researcher to draw conclusions, and it is also helping to interpret it easily by any person. I think that's all. I have taken up all the queries. In case there are some other queries, please let me know. Otherwise, that is all from my side. Uh, all right. Thank you so much. Thank you so much, everyone. Now I'll sign off from this meeting. Thank you so much.
Yeah, thank you so much for your presentation. Before I close this event, for our participants, please open your camera. Take a picture on the control screen. Okay, 1, 2, 3. Okay, another 1, 2, 3. Thank you for your participation. Finally, we come to the end of this lecture today. Dr. Simanpreet for the wonderful information and sharing your knowledge. We hope this information will be beneficial for our participants. At least we hope to have a collaboration in the future with Chandigarh Group Colleges Jhanjeri, India. The visiting lecture for the end here. We appreciate you. Thank you and